I solve a one-step equation? First, we need to know some of the properties of equality that relate to solving equations. The addition property of equality allows us to add the same value to both sides of the equal to sign and keep the equation balanced. Adding the same number to each side of an equation keeps both sides equal or balanced. Our subtraction property of equality allows us to subtract the same number from both sides of an equation and keep both sides equal. You are going to use inverse operations to solve an equation. Inverse means opposite. The inverse of addition is subtraction. So to begin with, I have a one-step addition equation. X plus 1 equals 9. When I say box the equal to sign, what I would like to see you do is box it off like this, with these bars letting you know that when we cross from the left side to the right, and later in this unit from the right side to the left, I have to make sure I'm doing the exact same thing to both sides. Next, this is an addition problem. So I'm going to use the inverse operation of subtraction to solve the equation. The inverse or opposite of adding 1 is subtracting 1. 1 minus 1 is 0. We say that cancels out. And this leaves me with x equals 9 minus 1 is 8. Our next example is a subtraction problem. I'm going to box off the equal to sign to help me remember that whatever I do on one side, I have to also do on the other. Because this problem contains subtraction, I'll use the inverse operation of addition to solve the equation. The inverse or opposite of subtracting 7 is adding 7. Again, make sure you do it to both sides in order to keep the equation balanced. Negative 7 plus 7 equals 0. We say that cancels out. That leaves us with y on the left. Negative 2 plus 7 is 5. There are some additional properties of equality that we need to know. The multiplication property of equality allows us to multiply both sides of the equation by the same number and keeps both sides equal or balanced. The division property of equality allows us to divide both sides of an equation by the same number and keep both sides equal. So looking at my first example here, I'm going to box off or block off the equal to sign. Remember that when you have a number right up against a variable like this is the negative 3 is the coefficient. We are multiplying the coefficient by the variable. This problem is negative 3 times x. The inverse of multiplication is division. Negative 3 divided by negative 3 is 1. That leaves us with x. 12 divided by negative 3 is negative 4. Our next example is negative x equals negative 8. In this case, we have a coefficient of negative 1. Mathematicians don't write the 1 as a coefficient in front of a variable. It's implied. If there's no number there, you assume the coefficient is 1. The opposite of multiplying by negative 1 is dividing by negative 1. Negative 1 divided by negative 1 is 1. That leaves me with x. Negative 8 divided by negative 1 is positive 8. Our next example is a division problem. The fraction bar is another way of showing division. The inverse of dividing by 2 is multiplying by 2. 2 divided by 2 is 1, leaving me with x. 7 times 2 is 14. And our last example for this set of notes is also a division problem. Y divided by negative 5 equals negative 100. The inverse of division is multiplication, so I'm going to multiply both sides by negative 5. Negative 5 divided by negative 5 is 1. That leaves me with y. Negative 100 times negative 5 is positive 500. At this point, you should write a summary. You should write a guiding question for this section of the notes. And you should write a guiding section for this section of the notes. So 2 questions followed by a summary.